Okay, let's do number 6. Number 5, yeah, okay, we have done already.
Yeah.
Okay, number 6. A metal wire in a circuit has a length of 1.8 meter, cross-sectional area that total number of electron charge carrier in the wire is 2.3 times 10 to the power 23. There's a current in the wire so that the charge of 172 Coulomb moves past a fixed point in the wire in a time of 2.5 seconds. Show that the number density of free electrons in the wire is that. Right? Number density is number per unit volume lah. Yeah, understood from here. So you just have to use that law. Number density is number divided by volume, cross-sectional area times L. So number, that's your number. Cross-sectional area, right? That's the cross-sectional area. Length, that's your length. Right? Get your answer. Two significant figure. Calculate the average drift velocity. Right? Use the formula NQAV. Right? V take NQA down. Right? Q becomes E. Right? The charge carrier is the electron. Then put in your value, 172 Coulomb.
Okay.
Then 2.5 minutes. Change it to second times 60. Area, and N is from here. And then charge on the electron. Charge on the electron is that one there. Okay. Drift velocity.
Yeah.
Any comment?
Oh,
This is Q lah. Q divided by time lah. This is your time. Okay, I didn't show the step lah. That's your time. Right? Q divided by time. Okay. A battery of electromotive force 9.6 volt. Negligible internal resistance. You have two fixed resistor, and a thermistor. The fixed resistor have a resistance of 3,400 ohm and 5,800. Reading on the voltmeter is 6 volt. This is 6 volt. Calculate the current in the resistor or resistance there. Okay, no internal resistance. So calculate, right? E minus V. V is across here. Right? There's a current through here. Trolley current through here. Right? E minus V is the potential across here. E minus V is potential across here. Divide by that resistance. Then you get the answer. Can. Anything?
yeah.
Okay. Calculate the resistance of the thermistor. How am I going to do that?
Okay, let me check.
This one is a voltmeter with high resistance, so you don't have to worry. The current through here and the current through here is the same. Right? We have just calculated. That's your current. Okay. P PD across this one is the current through it times that resistance. No? The current we have calculated. In case you've forgotten, we have calculated as our current. And that resistance. So that's a PD across here. So next thing is we can PD across here. Right? We know this is 6 volt. That voltmeter reading is 6 volt. So minus that potential is 2.1. So it's 3.9 here. 3.9, the current is that one there. So resistance, resistance is V over I. V is 3.9. Right? I is that one there. So it's 6300 ohm. Initial stored energy in the battery is 2.6 times 10 to the power 4 joule. Assuming that the EMF of the battery is constant, determine the final energy stored in the battery after a charge of 330 ohm has moved through it. Right? Energy spent is EQ, lor. EMF times Coulomb times charge. Sorry, it should be charge rather than C. EMF times charge from the definition of EMF lah. Okay, energy spent that's 9.6 volt times your charge. That's your charge. Final energy, right? 2.6 here minus your that one there. Round it off to decimal place. Okay,
Hmm.
no comment.
Okay.
The environment condition change causing an increase in the resistance of the thermistor. That increase. State whether there is a decrease, increase, or no change. Temperature of the thermistor. What is going to happen? The temperature of the thermistor.
Decrease.
Yeah, told that
Increasing.
increasing in resistance, so it decrease in temperature. Okay. Current in the thermistor.
Increase.
Decrease because total resistance increase. So current decrease. Potential different across the thermistor.
Increase.
Increase. Is sharing. Higher resistance, higher potential different. Okay.
Yeah.
An isolated stationary nucleus X decay by emitting an alpha particle to form a nucleus Y. Y and Z nucleus Y and nucleus Z are isotopes of the same element. By comparing the number of protons in each nucleus, state and explain whether the charge of Y is less than or greater than or the same as the charge of nucleus Z. Okay, what's your answer?
I put Y and Z of the same proton number.
Y and Z equal number of protons. They have the same charge. How about nucleus X?
This is
What is it? Yep, nucleus X. What do you
uh
put? Can't hear.
so I think my answer is wrong.
My answer.
Uh
My answer is wrong. Y and Z,
No, no, I mean, no answer, no answer.
nucleus X is no answer.
No. I mean, I didn't do this one.
Oh,
I
you
don't
didn't
know how to.
do, but I can understand the answer lah.
Ah,
You cannot better ask me, I explain to you. Y has two fewer electron than X, right? Alpha decay. So he lose two electron and he lose two proton. So Y has less charge than X. In alpha decay, A decreased by 4, Z decreases by 2. Can see the reasoning?
yeah,
Okay,
okay.
use the principle of conservation of momentum to explain why nucleus Y cannot be stationary immediately after the decay of X. Can?
I put X. X has no momentum since it's stationary.
X is stationary, so no momentum initially. So not complete. Have to say the final momentum is also zero. So
Oh yeah, yeah.
that require your nucleus Y and alpha particle to be equal and opposite momentum. Total momentum before decay is zero, or X has zero momentum. Total momentum after decay must be zeros. So Y must have equal and opposite momentum to alpha particle. So cannot be stationary, must have a speed or velocity. Okay,
Yeah.
okay, we have completed that. Let's go to our next paper. Okay, that's the answer. May, June 2023, paper 1, 2. Okay, let's go over the question number 1. A stone sinks in water. What is the possible value of the density of stone? Yep. What is your answer? How are
Should
you reason?
be should be more than the density of water.
Okay, so what would you suggest?
Highest one, D. Yeah, D.
Not necessary. It can be B, can be C, can be D. So stone is usually B. The density won't be so high.
I
Okay,
mean, they didn't say what stone though.
2000 good enough. 2000 is greater than 1000. Okay now.
Okay. I mean,
Basically, this one require you to have some idea. That's why it is in a sense not fair. Cannot be donkey.
yeah, it's not
It's
fair.
either B or C. But C is a bit too high. Okay,
Why donkey cannot?
donkey is too high. Mercury is only 13 times 10 to the power. Uh, if it's mercury is 1.3 and 10 to the power 4. So it's too high. So it's either B or C only.
Wait, is
It
mercury
also,
the densest element?
mercury is the densest. So it should
Oh,
know it's about 1.3 times 10 to the power 4. 1.4 1.4 times 10 to the power 4. Okay now.
yes.
Okay. Which unit is the largest and which unit is the smallest?
I think it's C.
No, donkey. Pico is 10 to the power minus 12. Micro is 10 to the power
Oh,
minus 6.
true.
This is 10 to the power 12. This is minus 12. Okay,
Yeah.
what's the answer? Mass given, diameter given. Yeah, told is a solid sphere. What's the uncertain? What's the percentage uncertainty in the density?
Well, let me open my. I forgot.
Okay, a volume, right? 4 third by R cube, or 1/6 by R by D cube. So your percentage, right? Uncertainty in volume equals to 3 times uncertainty in diameter. So 3 0.4 divided by 1.87 equals 6.4%. Then your go to density after you have found the percentage uncertainty in volume, right? This is a short form. Then density is mass over volume, right? Percentage density in mass plus percentage density in volume, right? Mass is given 0.1 over 32.5 times 100. 6.4, we already calculated it out. That's 6.7 donkey. Okay.
Mm.
In fact, you can roughly guess already lah. This already 6.4 already. This one is likely to be mass is likely to be very small. So you don't need to worry to calculate it anymore lah. Answer is donkey lor. Okay. An aircraft travels along a horizontal path. Two of the forces that act horizontally on the aircraft are the thrust force of the engines and the force due to the wind. The vector diagram for which is shown. The vector diagram for this is shown. Right? It's shown here. That there's already kind of draw for you diagram. Which vector represent the resultant force acting on the aircraft due to these two forces? What is your answer? Complete
Uh,
the diagram.
yeah.
There's the answer. C. Okay.
Yep.
A ball travels from point X to point Y around a semicircular track of radius 1.0 meter. As shown, this is a repeat question now. What is the displacement of the ball from X to Y? Yep, X to Y. That's X to Y.
2 meters due south.
Good. 2 meter due south. Right? Radius is 1. Diameter becomes twice of 1. It's 2. Okay, a rock is launched vertically upwards from the surface of the Earth, and an identical rock is launched vertically upwards from the surface of Mars. Each rock is launched with an initial velocity of 12 meters per second. That's 12, that's where it launched. Each rock then reaches the maximum height above the surface before returning back down to the surface. The velocity time graph for each rock is shown. In both cases, air resistance is negligible. What's the difference in the maximum height of the two rocks? How to find the maximum height? Right? This one you throw the rock upwards. So you take upwards as positive. So that is where it reaches the maximum height. Right? Maximum height, the velocity is 0. Then it comes down again, no? Right? At resistance negligible, it comes down to 12, it start at 12, it end at minus 12, no? Same as this one. So what's the difference in the maximum height of the two rocks? What's your answer?
So I put C.
Area of this triangle, no? One of them. The other one is area of this triangle. Right? Maximum height occurs when velocity is 0 and is given by area under the graph. Difference is half 12, right? That's your 12. Half times this one is about 3.2. Then this is 12, half 12. That's why the half there, the 12. This is 1.2. Right? Read carefully. You make mistakes, sorry. 12 meter. The answer is A.
Oh,
Okay.
yeah.
Which statement describes the mass of an object?
Oh, this one this one I put C.
C. C. That's defined by
Yeah,
the syllabus. Okay, define the syllabus. Resistor.
because mass has nothing to do with vector, right?
Nothing to do. It's just that we obtain it from first Newton's first law. You cannot move unless you push it. So it's resistant to of object to changes in motion. Inertia. Okay, memorize.
Yeah.
Lower form you define it as a quantity of matter. Sometimes they will accept it but it's better to follow the syllabus resistant object to changes in motion. A submarine of mass 3,200 is is at rest underwater. The total mass of submarine is certainly decreased by 200 kilograms by pumping water out of the submarine horizontally in negligible time. So upthrust acting on the submarine is unchanged. The change in the total weight of the submarine causes it to accelerate vertically upwards. What's the initial upwards acceleration of the submarine? What is your answer?
It says C.
That's your weight acting as your upthrust. So the first stage is new mass, right? You pump 200 kilogram out. So the new mass is 3,000. Right? Initial equilibrium, upthrust equals to mg. So mg is m initial is 320 plus 9.1. So that is your upthrust. So now the upthrust acceleration is F equals to ma. This is after you have lost the water. So this is a new mass. This is the upthrust. So upthrust minus your, I'm taking all to the power of 4. This one also the same, right? 0.3 take to the power of 4, right? 3,000, 10 to the power of 4 is 0.3, and 9.81. So A is 0.67, 0.657. So answer is B. Can
Yeah.
anything else to clarify or you understand?
No.
No, okay. A box in air slides with increasing speed down a rough slope from P to Q. That's your P, that's your Q. The slope surface exerts a constant frictional force on the box. Right? Frictional force is constant. It's going upwards. The box moves from P to Q. There are changes in the magnitude of its acceleration and the total resistive force acting on it. Which row describe the changes? Okay,
D.
donkey. Is it?
No, cat.
Cat. Okay, let's see. That's the weight. That's friction. There's your weight acting downwards there. There's your friction going upwards there. There's your air resistance. Right? Component of weight down the plane provides a constant applied force. Right? So the component of this weight is down there, provide a constant downward force. Air resistance increases as speed increases. So total resistive force increases, acceleration decreases. Donkey. Can.
Wait, what? Teacher, why does the acceleration decrease?
There is acceleration decrease. Let us call this force X. Let's call this force X. This is X is constant. Right? X is a component of W of this W. So it's constant. But this one is increasing. So the resultant force is X minus F minus air resistance. Right? Component of weight down the plane provides a constant force. So as this increases, the resultant force decreases. The acceleration decreases also. Can.
Uh,
This one is memory work only lah. See how your teacher asks you to memorize. So you memorize this straight away, then the answer is what?
A.
Answer A. Lor. If the any arrow changes, then it should become negative. Lor. A rod is pivoted at O. That's your O. A force is applied. That's your force. To the rod at point W. That's your point W. As shown. What's the moment of the force about O? Yep. What's your answer?
D.
Force and perpendicular distance. B. Can.
Wait.
This is the force. This is the force. That's the perpendicular distance.
It's all the way there. Okay.
You got 10 more minutes only. Okay, now happy with that?
Yeah.
Okay, what's the
Okay.
value of F? Right? That's your hinge at X. Held horizontally by this force. And this 30 degrees. This is 60 degrees. What is F?
Uh,
Taking
yeah, give me a
moment.
moment.
Taking moment about let XY be A. Right? Taking moment about X is easier. Lah. That's the easiest way taking moment about X. Right? So clockwise moment equals some anti-clockwise moment. So this is the whole thing is A. So this is half A. No? Half A times 10. No? That's your clockwise. Anti-clockwise is this one. Is F. right? It's A, and then resolve this vertically, perpendicular component F sine 30, right? That's your answer.
20 ah. Donkey. A donkey.
No, cat.
What?
Did you make some mistake somewhere?
Um,
Actually, the same. This is half. This is half. A and A cancel off. So it's 10. No? Where is your mistake somewhere? Found your mistake?
I use trigonometry.
Trigonometry is difficult because there is another force here. There's another force here. Right? It
Uh,
pass through here. It pass through here. It may make life more complicated. Okay? Because we don't know. We don't know the magnitude of force. We don't know the angle. Right? Taking moment is easier. Okay?
okay. Mm.
Two solid Q, X, and Y are made of material of the same density. X has twice the mass of Y. X has twice the mass of Y. Qx has the side of X. Qy has the side of Y. What's the ratio of XY? What's the answer? Right? You're working with mass, so let the mass of Y be M. Density is mass over volume. So density of Y, right, is a cube. So the volume is Y cube. And then they are made of that material of same density. So density, right? I just take this cross multiply lah. Density there. Then mass is for Y lah. Then for X, same X over X cube. Mass is now you are told that X has twice the mass of Y. Density is the same material. Then you take the ratio, X cube or Y cube is 2m over rho. Then this goes upside down. Rho and rho cancel, and can cancel is 2. Then take the cube root of 2 rho. Can. Yep. Which step is not clear?
Mm. Yeah, it's good.
What's the answer? What's the difference in pressure due to liquid between level P and Q? Right? Pressure difference between these two levels. Right? U delta H rho G rho. Right? This is 10. This is 6. So the height is 4. 4 cm, change it to meter. Density is 2000. G is 9.81. Can A.
Oh, right.
Right? This is memory work only. Nothing much can do. Input power, power loss, output power, what efficiency of turbine.
Efficiency of turbine is output over input.
So what's the answer?
Donkey ah.
Okay, good.
Wait, no, 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 no.
Donkey,
Yeah, it is, it is.
you don't consider the power
Yeah,
loss.
yeah, true.
A variable force is applied to ensure that a constant power is supplied to a train. Which graph best follows the variation of force applied with the velocity v of the train?
Directly proportional. Or with momentum should be donkey ah.
Donkey. Right? Using this formula, P equals to Fv. Right? P is constant power. So it's inversely proportional. Right? Inversely proportional. B is constant. So A, hyperbola.
I thought if you apply more force, the faster the train will be.
No, this one, the power is constant. So more force, lower velocity. Higher velocity, less force. Okay
Oh,
now.
what does it mean about?
Say again. You must read the whole question. Right? This one tell you constant power. Then they tell you
Oh,
force, velocity. So this must be related by the formula. And rewrite
okay.
it. And this is how you argue it out. That's the graph. Hyperbola.
Mm,
Can or not?
yeah.
What's the answer? A block is released from rest and slides a distance x from the straight slope. The slope is at an angle of theta to the horizontal. That's theta. So this one is also theta lah. The slope is frictionless, air resistance negligible. The free fall is g. The expression gives the final speed of the block. Right? Linear motion, taking down the slope as positive. Okay, so we are taking this line down the slope. So g is normal g. The acceleration is normal g. The acceleration is this one. So it's g sine theta. Distance is x. Initially, release is from rest. Then you choose the right formula. V squared equals u squared plus 2as. Right? U is 0. 2a is there. S is x. Can?
Yeah.
What is meant by spring constant of a spring?
I think constant is being extension.
So what's your
Wait,
answer?
F equals kx.
F equals to
F
kx,
over
yeah?
x.
So one
F over
k.
x. Force per unit extension.
Hmm. Okay. You got 1 minute left. A child holds a thin metal wire that is attached to a kite. The graph shows how the extension of the kite varies with extension. A gust of wind increase the tension from 100, from 100, 150 Newton. What is the change in elastic potential energy of the wire caused by the gust of wind? Yep, what's the answer?
Oh, this one 1 over 2 kx square. 1 over 2 fx.
Yep,
Yeah.
E equals half
A.
Fx.
A. A.
So area of
What?
trapezium